All right. Hello, my little babies. I guess you guys aren't so little anymore. This lesson, just if you're listening right away, the last few questions are definitely the most important ones, but the rest of them you need to know how they work as well. So once you feel pretty good on these, make sure you understand how the last few work. I think you're going to do a really good job with this. Let me know if you have questions, obviously. I'm going to go real slow on how to do it, but you can do this very fast if you learn the process. All right. So it says, describe the effect on the area. So for all of these questions, we're saying what would happen to the area if, in this case, if you double the height. So let's talk about the current area. The current area of a triangle is 1/2 base times height, right? If I were to double the height, let's see. The current area would be 1/2 times 3 times 4, which is 12 divided by 2 is 6. That is the current area. What do you think the area is going to be if the height was changed to the number 8, right? If we doubled just the height. So let's take a look here. The area of a triangle is 1/2 base times height. 1/2 times the base is 3, and the new height is 8. So let's think that through. What is that? 8 times 3 is 24, divided by 2 is 12. So if we doubled the height, what happened to the area? The area is doubled. Boom. Nailed it. Let's talk about why that's true. So if I just focus on the formula, right? Area equals 1/2 base times height. What if I just double the height? So you don't even need this to answer this question. You do not need that triangle to answer this question. What happens when you double the height? 1/2, the base is the same, but what does the height become? It becomes 2 times the height, right? So if I clean this up, 1/2 times 2 cancels out, so that area is base times height. So how does this area compare to this one? If I have 1/2 base times height, and then I have base times height, what would you have to do to that number to get that one? You would have to double it. So again, the area would be doubled. So based off everything I just talked about, what do you think would happen here? If you multiply the length by 1/3, what's going to happen to the rectangle? Okay, think about it. I'm going to work through it. Area of a rectangle is base times height. So, or you can say length times width. And in this case, that would be 12 times 5. So this area is 60. What do you think is going to happen when I multiply the length by 1/3? And the length is generally the longer of the two. So if 12 is multiplied by 1/3, now it's the number 4. So what is the new area? Area is base times height. That would be 4 times 5, and that area is 20. So what happened? Boom, you nailed it. 60 times 1/3 is 20, right? So the area, what happened to the area? The area is 1/3 the size. Area is 1/3. Perfect. What if we did that based off the formula? The formula is area equals base times height. Or actually, they use the word length. I should use length. Let's go ahead and do it. Length times width. And so what happens? We're doing 1/3 the length times the width, which I could rearrange that as 1/3 times the length times the width. Isn't that all the same stuff? So isn't this the original area, length times width times 1/3? Isn't that all that happened? Yeah, it is. So the area is times 1/3. All right, what is the effect on the area of the rectangle if you triple the width? Take a guess. What do you think is going to happen? Just the width is tripled. So let's see. Area, we're going to do length times width this time. Base times height, length times width, same thing when it comes to a rectangle. So the length is 10, the height's 8, so the current area is 80. If I triple the width, this is 24 now. Area equals length times width. That would be 24 times 10. And that is 240. What happened? How do you go from 80 to 240? Times 3. The area is tripled. Let's look at it based off the formulas. If I said area equals length times width, and then I told you to triple the width, wouldn't that be length times triple the width? And we can rearrange this to be 3 times length times width. Isn't this just 3 times the original area? Yes. So all 3 of these examples, you did not need a picture. Okay, so let's go to the next phase where we're maybe doing more than just one dimension. We're changing multiple dimensions. We're doubling the length and tripling the width. Let's think real hard what that would mean. Predict, what do you think is going to happen to the area if I do that? So let's get the current area. Area equals 7 times 6. So the current area is 42. What would happen? We're going to do 2 moves. We're going to double the length. It's 14 now. And we're going to triple the width. That's 18 now. So the new area would be 18 times 14. Woo! What is 18 times 14? Was that 252? I don't know. I'm going to type it in real quick, make sure I got it right. 18 times 14 is 252. I got lucky. So 252. So how do you go from 42 to 252? Well, what is 252 divided by 14? It is 18. So the area is 18 times bigger. Wait. Messed up, my friends. Yikes. The area is not 18 times bigger. I typed in the wrong thing. Sorry. 252 divided by 42. It's 6. It's 6 times bigger. 6 times bigger. Okay, there we go. I was like, what? 6 times bigger. All right. So let's take a look at it based off the formula. Area equals length times width. And what did we do? We doubled the length and we tripled the width. So isn't that, we have 2 times 3, isn't that 6? And then we have length times width. Isn't that just 6 times the length times the width? Yes. So what ended up happening? It was 6 times bigger. All right, next one. What would happen if you multiply the base by 1/2 and double the height? I want you to try to predict it before I do it. I'm going to work it out. This is 1/2 base times height. This is 1/2 times 6 times 8. That would be 24. So the current area is 24. Let's adjust it. The base is cut in half, so it's 3. The height is doubled, so it's 16. So the new area would be 1/2 base times height. That'd be 1/2 times 3 times 16, and that would be 24. What? So nothing. No effect. Nothing. Okay, let's talk about it. Let's write the formulas down. So we're running out of space. I'm going to do it up here. So the original area is 1/2 base times height. So what would happen if we did what? Multiplied the base by 1/2. So 1/2 times the base, doubled the height. Well, let's look at this. 1/2 times 2 just cancels out. So we're left with 1/2 still in front, base and height. Well, that's just the original formula. If you double one dimension and cut another dimension in half, the area is actually unchanged. It's the same area. Describe the effect if you triple all linear dimensions. Linear dimensions are lines, anything that's represented with a line. So 14 would be tripled, 12 would be tripled, the hypotenuse would be tripled. Anything in this triangle that you could draw with a line would be tripled. The altitude would be tripled. Any linear dimension would be tripled. So let's do the current area, 1/2 base times height. That would be 1/2 times 14 times 12. That would be 84. I don't want to be wrong, so I'm going to type it in. You never know. Sometimes you're just not on it. It's 84. Okay. So the area is 84. And then we're tripling all linear dimensions. So 12 becomes 36. 14 becomes 52. 42. See, sometimes you don't have it. 42. All right, so the new area would be 1/2 base times height. That's going to be 1/2 times 42 times 36. Let's see here. That's going to be harder to do. That's going to be 21. 36 times 20 would be 720. Plus 36 would be 756. I'm going to type it in just in case. I'm probably wrong. I don't know. I got it. 756. So what happened? So what is 756 divided by 84? It's 9. So the answer is the area is what? 9 times bigger. Let's look at it based off the formulas. So let's do area equals 1/2 base times height. That is 1/2. All of them are tripled, so that's 3 times the base and 3 times the height. Well, what would happen here? 3 times 3, that's 9. So I'm going to pull a 9 to the front. And if I pull that 9 to the front, aren't I left with 1/2 times the base times the height? It is 9 times the original formula. 9 times the original formula. Nice. Every linear dimension of a polygon is multiplied by 1/4. What's the effect on the name gives a picture. What's the effect on the area? A polygon is area equals 1/2 AP. So it says every dimension is multiplied by 1/4. So 1/2, the apothem would be multiplied by 1/4. And the perimeter would be multiplied by 1/4. Those are the two linear dimensions in that formula. So if I do 1/4 times 1/4, I would get 1/16. And that would leave me with 1/2 A and P, which is 1/16 times the original formula. So what would happen to the area? Area is times 1/16. Or could you say it's divided by 16? Yes. All right. Two similar cones have this ratio. The surface area is that. Find the surface area of the second cone. So these last two problems we're supposed to be able to infer or be able to use inductive reasoning to figure out that if all the dimensions are changed by the same number, if they were tripled, the area was times 9. If they were 1/4, the area was times 1/16. How do you go from 1/4 to 1/16? How do you go from 3 to 9? It is the ratio squared. 3 squared. If you knew the how to work this out, it would be times 3 times 3. That's how we got times 9. Times 1/4 times 1/4. That's how we got times 1/16. Up here where the numbers were different, times 2 times 3 was times 6. Times 1/2 times 2 is times 1. That's no change. Times 3 is times 3. Times 1/3 is times 1/3. Okay. So if the ratio is 3/5, and we've done these problems before, you have to square that ratio to work with area. Because if this is a similarity ratio, that implies that it's all the dimensions. Every dimension of these shapes have this ratio 3:5. So that's the ratio. It says the surface area of the first cone is 250. Find the surface area of the second cone. This is what your setup would look like. So you reduce vertically, can't do it. You reduce horizontally, can't do it. So then you cross multiply. So you would have 9 times x. 25 times 25 is 625. Add a 0. Make sure I got that right. 25 times 250. Got it. And then divide by 9, and that's going to be your answer. I don't think that's going to reduce, and it's not. So the surface area of the second cone would be that. A lake has a perimeter and an area of 400 and 650. A scale drawing is done with that ratio. So it's 100 over 9. But we need to square the ratio to work with area. Oh, we were going to do perimeter and area. So what do we do with perimeter? Do you remember? The perimeter, you just leave it alone. So let's do perimeter first. So the perimeter is the same ratio. Area is always the squared version of the ratio. Do not square these numbers. Don't do that. To work with area, you have to square the similarity ratio. To work with perimeter, you have to use a linear ratio, which is what that is. So 100 over 9 would be 400 over something. Well, remember, we can reduce vertically, nothing here, but we can also reduce horizontally. That'd be 1/4. So this answer is going to be 36 when we cross multiply. The next would be squaring the ratio to work with area. So let's go back to 100 over 9. We're going to square that. That's going to be 1, 2, 3, 4 zeros over 81. So it's 1, 2, 3, 4 zeros over 81 is going to equal the area we have, 650, over what we want. So we reduce horizontally. That doesn't work out. I'm going to type this in. 1 with 4 zeros over 650. That reduces to 200. Let's change color. That reduces to 200 over 13. Then we cross multiply. That would be 200x. I'm just going to type it in. 81 times 13 is 1053. And then divide by 200. I get 1053 over 200. And that would be the new area. So this is the area, and this is the perimeter. Another area and perimeter problem. It says if the photo of the drawing has an area of 81, was the perimeter? Okay, so we know the original area and we know the new area. So the area ratio is new, or is the one that we have, over the photo 81. And we want to work with perimeter. So we just talked about this. If you take a similarity ratio and you square it to work with area, what do you do to an area ratio to work with perimeter? Tell me. Tell me. Tell me. Well, you're going to square root it. So that's going to be 15 over 9. So to work with perimeter, we have to have a linear measurement, right? Like they didn't give us any units, but this would be units squared. But perimeter needs to just be units. So how do you go from units squared back to units? You're going to have to square root it. So to work with perimeter, we would do 15 over 9. Perimeter ratio equals the original perimeter over the unknown. So let me make sure I got this. The square root, 225 over 81 is 15 over 9. Now that reduces, so we reduce vertically. That would be 5 over 3. And then 5 and 275, 20, 40, 15. So 55, let me make sure I got that. 15, so 5 over 275 reduces to 1 and 55. Yep. So x times 1 would be x. 55 times 3 would be 165. And that would be our answer. Woo! Fun questions. Closing her up. See you next time.